Hi, guys, and welcome to Weird. I'm Amy, a nurse.
And I'm Katie, a science writer.
We're cousins, and we have an unhealthy obsession with the bizarre side of science.
This is Weird, the podcast.
We're glad you're listening in today. This is Weird, the podcast, where we take a nosedive into the wacky parts of the world.
We each have an odd science topic that we've researched, so we will start by flipping a coin to see who presents first. By flip a coin, we mean Amy tapping a screen because cash is obsolete.
I actually found a quarter in my cup holder in my car today, and I thought about bringing it inside because
I actually found one the other day too, and I wanted to flag it for.
We should use this. Okay, my heads again. Okay.
Sure.
It's tails. So you go first.
Okay. Cool. All righty. My topic is all about bugs today, specifically ants, but maybe I'll do my little show and tell first before I dive into my topic here. So, I mentioned on the last podcast, I have a slew of reptiles living in my house. And so, because of that, I have started a very small scale mealworm breeding project in my bedroom. I breed worms for my lizards to eat. And I think probably not a lot of people know this, but the mealworm, which everyone knows what that is actually just one of the life stages of what's called the darkling beetle. So a mealworm, and I will show you for those of you watching on YouTube. Here's a mealworm. You all know what that looks like. But what happens is they start to go totally still. So, of course, now he's moving now that I'm picking up. This one is at a weird angle because he's
for those of you that are listening just audio, they look like little brown worms.
Yes, it just looks like a standard little, I think most people have seen.
Like a mealworm.
Like a mealworm. Yeah. It's just a little wormy guy. Looks like a little 1 inch long.
They're like pan. They have tiny legs.
Yeah, little tiny legs. Only in the front part of their body, though. The whole rest of their body does not have legs. So that's kind of how you know something is like in a larval stage versus like a centipede or something that is its adult form. Is the legs will span like the length of the body versus that mealworm. He only has like 6 little legs, like a millimeter from his head, and then the rest of it is just his body that he drags around. So what happens is after a few weeks of living in this form, they get a little bit stiffer. They kind of start curving into like a little bit of a C shape, and that's how you know they're about to pupate. So the next stage after the worm is the pupa, and this is the weirdest thing I think that exists. This is a mealworm pupa. It's moving a little bit. Google mealworm pupa or just mealworm life cycle if you want to see more detailed images.
But or maybe don't because they're gross.
Or don't. Yeah, they're really weird looking. But it literally looks like a little alien. It has no legs, no eyes. It's like this little alien cocoon-like creature. And then slowly over time, a little blob. But it looks like a little weird alien face in there. But that they shed off their little skin, and then that guy's inside the worm. You know, they turn into that, and it happens very quickly. And then they're in that stage for a little bit, and then over time, their eyes start to develop, their little legs, and then one day they turn into this little guy, little black beetle.
Yeah, and honestly, he just looks like a little like standard beetle.
Yeah, just a little like it's if you saw like a standard type of little, little beetle guy like crawling down the sidewalk. Like, that's what they look like. That's the life cycles, and then of course eggs. So then those beetles lay eggs, which then hatch into those tiny versions of those little mealworms. They grow up, they turn into pupa, turn into beetles, and the cycle continues. And unfortunately, I had a specimen that died that I was going to show, and he died, and then he kind of like fell apart. I don't think he was very sturdy, but he didn't really fully make it from the pupa to the beetle stage. So his head and kind of the first part of his little thorax, or I think that's called the thorax, was in a beetle form, but his whole back end was still a pupa. And he was like, he only half transformed. So like poor guy. Yeah. And that happens sometimes with nature's not perfect. But yeah. Anyway, so just a little aside, little show and tell for
Oh, and last time I was at Katie's house, she showed me one of the little worms that had just hatched out of an egg. And oh my God, they're so small.
Yeah, they literally I mean, they look small next to a grain of rice. And like a regular
Yeah.
mealworm full grown that you kind of see, you buy at the pet store or whatever, it's like maybe an inch long. When they hatch, they're like maybe a millimeter long. I mean, like you almost have to use a
Yeah, they're
magnifying glass
tiny.
to even see them when they're like first hatched. So they tiny, tiny, tiny. And
Teeny
then,
tiny.
for a few weeks they grow, and then yeah, but it's fascinating. I feel like I've learned a lot about bug reproduction through this process. So if anyone was wondering if I was weird or not, now you know.
Yeah.
Now everyone knows how weird I am.
Secrets out.
The secret's
No.
out.
And just, in case you didn't get that from us being co-hosts of a podcast called Weird.
Exactly.
In case you just assume that we're just like totally regular people.
Exactly. Okay, so my real topic is ants who think that they're dead, but they are very much alive. So, a little bit of background: ants behave largely as a collective, and they're mostly blind and deaf. So they live their whole world by scent, by following the hormonal scent trails left by the other ants and the other scents that they excrete, because that's all they have to go off of. Is this? They live in this world of chemical signatures. And, that's part of them being such a social insect. And that really is how their colony thrives and how they all work together. The ant colony, it's called I believe it's pronounced formicary, is the official name of an ant colony. I'm probably not saying that right. And
right.
Normally they're all working together, to get food, lay eggs, take care of the colony. But of course, when there is live ants, they die. So with a large colony of hundreds or thousands of ants, obviously they die on a regular basis. So what happens when an ant dies, either in the colony or near the colony, is the ants take their little dead comrades to the ant graveyard. And this term is called necrophoresis. It was coined by a very famous entomologist. His name was E.O. Wilson. A lot of people have heard of him. He's a brilliant entomologist, and actually just passed away just a couple years ago. But he coined that term, and it's a sanitation behavior by the ants, because you can't just like leave dead bodies all over the place. There could be disease or other, risks to the colony if you just leave your dead bodies out. So you got to take care of them. You got to take care of them. We do that too.
You can't just leave your dead bodies just like in the hallway of the colony. Like...
Right. So, and yes, I'm sure as Amy is very familiar, when people die at the hospital, you don't just leave them there. You put them all in a place.
We're not supposed to just leave them there.
Oh no. Crap. Have you been doing it wrong this whole time?
Oh man, I've been doing it wrong this whole time.
Yeah, so that's what they do. They bring their dead to this graveyard, and that's how they make sure that, they don't just leave bodies everywhere. And a lot of insects do this. Ants do this, bees do this as well. A lot of these social insects, termites do it as well. But why do they do it? What signals the ant to take the dead ant to the graveyard? For a long time, they just thought, oh, well, they see the dead ant and, they must obviously, know that they're dead and bring it to the ant graveyard. But remember, ants are basically blind. They're basically deaf. So if an ant was sitting there dead, they wouldn't really know necessarily that it was dead. And so E.O. Wilson in the 1950s, 1958 specifically, he started taking these observations of ant colonies. And when the ant dies, it sits there, and it sits there for 2 whole days. The dead body sits there. They like walk past it like it's nothing. They just totally ignore the dead ant. And then on day 2, after 48 hours, they suddenly pay very close attention to the dead ant. They pick up the ant, they bring it to the graveyard, they take care of things.
It's always 48 hours later?
I think there's a little bit of fluctuation, but essentially approximately 2 days after the ant dies, they totally ignore this poor dead ant. They step over him. They, don't even like pay attention to it. But after
like,
2 days,
Fred laying in the hallway. It's so weird.
Fred, get up. So why? So he noticed this at first, and he started to test, like, okay, something must be happening at that point, at that 48-hour mark. And what happens is the ant starts to decay, as all bodies do after a couple days, and it starts emitting various different types of chemicals. And that is what makes the dead ant become visible to the other ants. Basically, he was totally invisible. He was scentless. He smelled just like an alive ant. But after a couple days, the various chemical signatures of decomposition made him become visible again to the other ants. And then they snapped into action, brought him to the graveyard, and that's how they know he's dead. Pretty crazy that like they live in this world of chemical scents, and that's how they communicate. That's how they know what's around them. But, E.O. Wilson, he wanted to figure out what chemical was actually doing this. So he tested a lot of different chemicals that happen when an insect decays. There's many different chemicals as any animal decays. It's a slew of chemical reactions. He found that it was oleic acid was the chemical that makes the other ants know that the ant is dead. So what he did was to come up to that conclusion, he had to dot little droplets of various chemicals on a perfectly fine, totally alive ant and see if the other ants thought he was dead or not. So he described his 1958 experiment. He said, let's see here. For weeks, my laboratory smelled like the combined essences of sewer, garbage dump, and locker room.
Yum.
He was testing all these different chemicals. Basically, what happened when he dotted a little bit of this oleic acid, which is a naturally occurring chemical. It's found in like olive oil, some nuts, cheeses. It's just a natural chemical that happens with like the decomposition process. When he dotted a little bit on a totally alive ant's back, he even kind of thought he was dead. And the other ants immediately looked at him. They looked over at poor old Fred, who's totally alive. He's got a little dot of this like little acid, but it's not an acid that actually is destructive. It's, a naturally occurring component of the decomposition process. So suddenly everyone thinks Fred is dead. So they all pick up Fred and they take him to the graveyard just because he has this chemical on his back. So they put him in the graveyard. And oftentimes what happens is the ant that had this oleic acid on him, they brought him to the graveyard and he sat there for a while, like contemplating his existence. Like, am I dead? I must be dead. But then eventually he sort of realized, no, I actually don't think I'm dead. So he'd start cleaning himself off. And then once he cleaned off all the oleic acid, he's like, okay, now I'm definitely not dead. Okay, yep, I'm alive. And then he just like walked back in, rejoined the colony, and they're like, oh, hey, Fred, glad to see you're fine. And then he just rejoined and went about his day.
He's like Jesus, Fred. It's like,
yes, yeah, that's truly
and Jesus ant like came back from the dead.
I know. Do you think that they like made a whole holiday after that ant? Like,
I know
that it inspired the ant culture to think that ant like was a Jesus ant.
I don't know.
Zombie ant.
It sounds like from what you're saying that they didn't really pay any attention to it at all. They were just like, oh, hey, man.
Yeah.
Hey, man. That was weird earlier when we brought you to the graveyard.
Yeah. And actually, I wonder if they knew it was the same ant because they live as a collective, they don't really have this sense of like individuality per insect. They very much live as this big common hive mentality. But I just thought that was so fascinating. And then I in doing some research, I came across another modern day channel that on YouTube. It's called the Action Lab on YouTube, and it's super fun, sciencey channel. Yeah, he does these like cool experiments. He decided to recreate this experiment just a couple years ago, and so in his little experiment, he did the same thing. He got some oleic acid, and he put a tiny little dot on the back of one of the ants. Popped him back in there, but for some reason, maybe the other ants were busy, or who knows, maybe it wasn't the right amount. But he was like, I think I'm dead, and he walked himself to the graveyard, and he just like hung out in the graveyard because he thought he was dead.
Oh no! Oh, that's so sad.
Poor guy.
How confusing that would be. Like to like have a very biological indicator that something is dead. And then you feel that about yourself. And so you just walk over to the cemetery and you lay down.
Yeah, I know. I'm trying to think of like how different that would be if like that's how we knew that those around us would be alive or dead. Like we go on cues of visual, of hearing, of feeling, but ants, like they live their whole world by scent. That's really the only way that they ever can sense anything is following scent trails. So yeah, isn't that nuts?
It would be very disorienting for the
ant. Know. No, poor ant. Can you imagine? And actually, related to that, obviously it gets very disorienting when the ant thinks it's dead during these experiments. But there's another phenomena is plural, right? There's another phenomenon where ants get very confused because they're following the scents of all their buddies. And if that path that they're leaving on the ground, that that they're kind of smelling along to navigate back to the colony or navigate to a food source or wherever they're all going. And I think maybe this can happen either if a lot of them are going out to gather food or something, or if the colony is like moving or something. But if that gets mixed up and that accidentally goes, they start going in a circle, like in a spiral. It's called, I don't know if you've seen videos of this, but yeah, Google this. Ant death spiral, or it's called an ant mill. So what happens is, the ants are going about their business. If a few of them accidentally kind of trace back into that spiral pattern, they will just keep following that spiral pattern, and they'll have no way of getting out of it, because then
Just
each one
forever
will
and
follow
ever.
the other one. Yes, like what's that Lamb Chop song? Like,
Oh
it's
my
the dance that
God.
never end.
Yeah.
And eventually, like, they will all die, because there's just nothing that can, unless someone physically like knocks some of them out, or moves some of them, like they will just be stuck in that cycle.
What?
And so, like, they have no vision to help them out, or hearing, or at least very little. They're just going on scent, and so all they know is that I'm just following the scent in front of me, following it in front of me. That's all they ever do. They're just like little, army soldiers, just in a line, just following the next one.
Have
And
no critical thinking skills.
yes, they have no, the poor ants have no critical thinking skill. Poor ants.
Poor
I mean,
ants.
is that much different than society today? Who knows? But
Yeah, that's
yeah.
it does make sense why Fred took himself to the cemetery.
Yes.
Having very few critical thinking skills about
I know. Poor
his existence, having a little bit of an existential crisis there.
I know. Poor Fred. Yeah. Even with that, ants are very cool. I wrote down a couple other cool ant facts. So there's over 12,000 species of ants so
Wow.
far. I'm sure we'll discover many more. Because if
Yeah.
there's that many, that means that I'm sure there's more out there. And they're found on every continent except Antarctica. They are one of the longest lived insects. There are some species of ant that live up to 30 years. Seems like a very long time. I'm sure the little ones that like you see outside maybe don't live quite that long, but comparatively to like flies and mosquitoes, that's a long time.
Yeah.
And they're like the strongest, fastest bugs. I think everyone knows that ants, can carry much more than their body weight, like 50 times their body weight. But they can also close their jaws at a speed of about the equivalent of like 140 miles an hour, like the speed at which they shut their little pincher mouth.
What?
So they're like the little powerhouses. Little
That's
ants.
crazy.
Maybe not so smart,
But
or at least not smart as an individual, but the hive mind is actually very intelligently designed, and has evolved to work as this big, unit, this big engine, all doing its part. So yeah, ants are crazy, man.
Yeah, ants are pretty. Yeah, they are. They are.
And poor ants.
The thing I was thinking about earlier when you were talking about the ant graveyard, I was like, is it just like a pile of dead ants, like somewhere in the colony? It's just like a pile. And they just like
basically
on the pile.
Essentially. Yeah, I actually wonder. I'll have to do more research on that. And yeah, from the like videos I was watching of these experiments, yeah, I mean it literally is like, and I guess anyone who's ever had an ant farm, which I've never had an ant farm. Can you believe me? Why have I've
oh my God, let's get one.
Like, I need to get an ant farm. I've
God, we totally
tried to make
one.
my own outside just with like dirt and sand, and that works, but like it's not a full colony. It's just the ones that I could like catch in a jar.
Yeah, because don't you have to have like a queen, right? So like
yeah, technically,
right?
I think you
like bees.
Yeah, I do wonder how much that would make a difference to their kind of everyday process. Like, do they have to have a queen to do all these societal functions, like make a graveyard, like make a nursery? Well, obviously they would need a queen to make a nursery, because there wouldn't eggs, I guess. Yeah, so I bet the whole, I guess, colony behaves very differently when there is a queen versus no queen. One day I'll have an ant farm, and maybe I'll get some oleic acid and I will do this experiment.
And
because that sounds fun.
And make a bunch of zombie ants that are just walking around thinking they're dead.
I know. Like, what would you do if you did it on multiple ants? Like, not only the ants that you want to be carried to the graveyard, but also the ants responsible for doing the carrying. And actually, there's certain, so any ant can technically like be the type of like worker ant that carries away dead bodies, but there is a specific kind of role of ant. You know, there's like the ones that take care of the eggs. There's
Oh my
the
god,
ones
there's an
that
ant
hunt.
coroner.
Yes, they're called the undertakers.
Oh my god.
Designated undertakers, ant undertakers.
That's amazing.
And they have a slightly like altered like development cycle that, you know, like every single type of ant like develops slightly differently to be more skilled at their trade, whether it's finding food, whether it's, you know, fighting off predators or whatever, you know,
Or carrying dead bodies.
Or carrying dead bodies. I don't know if they have to be stronger. I guess not, because any ant can carry way bigger than its own body weight. So maybe they just can't be grossed out.
Yeah. Like maybe they have to be like a little bit goth. Like,
yeah.
They like dress in all black and like
yeah. It's just I wonder if there's like a stigma in like the ant colony of like, oh, you're that type of
you're
ant.
an undertaker.
You're an undertaker.
Wow.
What got you to that point of your career?
Yeah.
Although that is a very cool career in ants and in people.
Yeah, I agree.
Yeah. Isn't that nuts? Like
that is so interesting. Wow.
I wonder what would happen. Yeah, like if you put a like acid on the undertakers and some other ants, like what if they all thought they were dead? Would the whole society would they all just like sit around like, are you dead? Am I dead? Are you dead? Wait, you carry me to the, and they're like, no, you carry me. No, you carry me to the graveyard. They would be very confusing.
I feel like if they basically communicate and live off of like scent, that if they all had the dead scent, they would all like the whole society would just collapse because nobody like they wouldn't be able to communicate with each other and they would all just
I know.
It'd be very confusing.
I wonder if anyone plans on doing an experiment like that.
I don't know. It sounds kind of abusive.
Yeah, maybe. I mean, maybe they could just wash them off right after. Like, just joking. April Fools. You're all fine.
You're all alive.
You're all good. I mean, luckily, it doesn't hurt the ant at all to put this chemical on them. So, you know, it's at least it's not, you know, harmful to them. So, like, maybe they could just dot it on the ants, see what happens. And
eventually, like, the ant would, like, clean it off, like, clean itself.
Yeah, because that did happen in many of the experiments, even the original ones. Eventually, the ant in question realized the truth.
Realized that it wasn't really dead.
He was like, I guess I'm still alive. I guess. Yeah. I mean, that's like me every Monday morning. I'm like, am I dead? Am I?
All right, time to go back to work.
Clean myself off. Go to work.
Yeah.
I mean, same.
Yeah, ants. Same.
There's a lot of cool ant facts. I think I said most of them that I was thinking of. Oh, there's another cool E.O. Wilson fact, though. So this I actually have known for a long time because I love E.O. Wilson. But he, at like 7 years old, 8 years old, he was involved in a little bit of like a fishing accident, and he lost one of his eyes. Well, at least most of the vision in one of his eyes. And even though he regained a little bit of it, he never had the ability to like see things clearly far away. He could only see things clearly when they're really close up. And that's why he became so fascinated with bugs at an early age. And that just shaped his entire life. So little 7-year-old E.O. Wilson.
Little nearsighted E.O. Wilson.
Know. But I mean, it did him good because he became one of the most influential entomologists, you know, of our generation or century. So yeah. Love E.O. Wilson.
Yeah.
But also careful when you're fishing to not poke at your eye.
Yeah. Don't do that. Not recommended.
Yeah, not recommended.
My topic is also I'm talking about shrimp. They're kind of like bugs. It's an
arthropod.
It's an arthropod.
Well, everything we've talked about today, mealworm and shrimp, I believe, are all arthropods.
Yeah, they are all arthropods. They all have an exoskeleton that they have to shed in order to get bigger. So, okay. I'm talking about two specific types of shrimp today, and we're going to start with the mantis shrimp. And I feel like a lot of people have heard of mantis shrimp before. Like, it's just a really weird animal, and like the Oatmeal has a really awesome comic about mantis shrimp that I highly recommend that you go and read. But the mantis shrimp is like, it's a shrimp, but it's really pretty. And there's two really cool things about the mantis shrimp. So the mantis shrimp, it's little where its claws are. It has these little like appendages that can punch things. And so it basically like punches like its prey and its predators. And it can punch with these little appendages with a force of up to 1,500 newtons, which is approximately equal to the force of shooting something with a .22 caliber bullet.
What?
Yeah. And it's like, I mean, it's really small. Like it's, it's like a little shrimp and it just like punches the shit out of stuff.
Like imagine if it was larger, like how forceful.
Yeah. Well, I read a thing that said that there's been accounts of it punching people, like because they're studying them. Oh. And it like breaks bones and stuff. It can like break like your fingers and stuff like that because of how hard it hits.
Wow.
Yeah. Or at least like cut you or like gouge you.
Yeah.
From its little, it has these little punchy things. It's kind of cute, but also like deadly.
Yeah. But I feel like there's a lot of things in life that are cute and deadly.
Yeah, that's true.
Wow.
But yeah, even cooler than that about the mantis shrimp is their eyes. So each eye has 3 focal points in it, with essentially pupils in each eye.
Oh.
So with each individual eye, they can perceive depth. They cover one eye, they can still have depth perception. Have like 6 pupils, like what we would as humans would consider like pupils. And within each eye, so like humans, we have 3 photoreceptors: red, green, blue. And that's like what allows us to see color. The mantis shrimp has 12 to 16, depending on like the species. There's different like types of mantis shrimp. So they can just see like a whole bunch of shit that we can't see.
Probably like, color we can't even think of.
Yeah. Yeah. Supposedly they can see like ultraviolet light and like infrared, and the other thing that they can see is like light, like differences in polarity of the light. This is a theory just based on what we know about their photoreceptors, but they've tried to make like cancer detecting devices, like cameras that are based on the mechanisms that the mantis shrimp uses to see. When you shine like polarized light at a cancer cell, the cell is so disorganized and structurally different that the light is refracted differently than when you shine it on a normal cell. So theoretically, mantis shrimp can see cancer.
Wow.
Which is like kind of amazing because it, I mean, we don't have any sort of technology like that can do that now. Just like look at something and be like, oh, that's cancer. So so that was really interesting. And I was looking up like what exactly does that mean, polarized light? I kind of went down this little rabbit hole about polarized light because I was like, I don't even really know like what that means. Like light has the way that the wave of light hits our eye can be either vertical or horizontal or anywhere in between. Okay. So we have like polarized glasses. Typically it's blocking like either horizontal or vertical. So not all of the light is actually getting to your eye. And that's why it like changes the contrast of things. Like if you have polarized sunglasses and you like look at a sunbeam, it looks different versus if you don't have them.
Right.
So so mantis shrimp, they essentially like they already have that and they can block out certain directional wavelengths. Something about electromagnetivity and magnetivity in there too. I don't know. Someone that knows more about light waves, like
some smart words.
Yeah. But
wow.
Yeah. So yes, but yeah, mantis shrimp, they can just see polarized light just with some of these photoreceptors that they have.
Right. So why do they have to have such good detailed vision, and why do they have to punch so hard? Is it for hunting?
I mean the punching thing I assume is for like hunting and protection. It seems unclear, like from what I was researching, like why they have to have so many photoreceptors, because it doesn't even, like from some of the articles that I read, it doesn't even sound like maybe they use all of them. So it's sort of unclear about like why do they develop so many, just because it just, I don't know, it just seems weird that they would be like, just because. Like,
yeah, there's got to be a specific like evolutionary reason why they would. Yeah, like that's crazy that they have, and then such good depth perception too, because you mentioned
yeah,
that they can have depth perception without having multiple eyes on the subject.
yeah.
And I guess that's because if they're punching something that hard, they better be punching the right spot.
Right? Yeah, they better
You know?
like figure out what they're hitting. Yeah, I mean, but their visual acuity is really good, and it allows them to identify things and move like very quickly. I actually had a friend in college, shout out to Kevin, who had a mantis shrimp. I think its name was like Zoidberg or something like that. But the thing was it was really pretty, and I assume like that it has so many colors just because like it can see and perceive so many colors. And so like I mean, probably like the mantis shrimp looking at other mantis shrimp, that's probably an advantageous thing to like be really colorful. If something that's looking at you, you know, can see all of your colors.
Yeah. And I imagine when they look at each other, it's something that's even more brilliant, not only that we can see, but could even imagine. Like you can't. And I think about that with like, you know, other animals that like can smell so well, for example, like even like, you know, dogs, you know, like they smell so well that like we can't even visualize how it would feel to like smell that well, to like have that strong of a developed like sense.
Yeah.
Or if you know, like a lot of people have seen this, you know, little kind of food for thought question is like, you know, hey, think of a new color that you haven't ever seen. You're like, I can't.
Yeah.
But like,
and now do that 9 more times.
Yeah.
And now you're a mantis shrimp.
Yeah, that's crazy. And not just colors, but yeah, like different wavelengths and different, like, well, I guess different colors are different wavelengths, but you know, like even beyond just the regular visual spectrum, they're seeing all sorts of different wavelengths.
Yeah, just well, they're able to see things that to us are like invisible, which just kind of blows my mind. It's just really weird to think of like that we can look out at the world and not see stuff that is there.
Yeah. And I guess that's perfect, you know, relation to my topic too, that like the ants, like they couldn't even see their buddy unless it had a certain scent and it was like invisible to them. And like things are invisible to us because we don't have a certain, you know, visual acuity as our senses, our and other species senses and like perception of the world around us, like truly is just very individual. And like you only know what's going around you by your senses.
Yeah.
And like everyone's senses are different. And, you know, unfortunately, we'll never experience what it's like to see something so brilliantly as a mantis shrimp.
I mean, and you think about, you know, like people who are colorblind, like they have even fewer cones than the normal person. Usually they have like one that's lost. But yeah, I remember there was a kid that I went to school with who was colorblind, and I went in lab one day where we like burn all the different metals or whatever to like see what color they burn. And he was like, I felt so bad because he's like, that's orange, right? And everyone was like, no, that's green.
Oh no.
Yeah. But I was like, even that, I was like, wow, he sees the world so much differently than I do. Like, that's so interesting.
Yeah, it's really fascinating. And even like, I think about that, even people who have their full ability to see color, there's no guarantee that like my blue is your blue.
Yeah.
Like, yeah, we called whatever that color is blue. But if we like had an eyeball transplant and we switched eyeballs, like would the world look totally different?
Yeah. Maybe your blue is actually my red. Who knows?
Yeah. Who knows? Like, I think it all depends on like how, and we'll never know.
Yeah. We'll never know.
Maybe we will. Maybe one day they'll have the ability to actually switch our,
to figure out if we get, maybe we can switch eyeballs someday.
I know. Well, I mean, they do like transplants, like corneal transplants and stuff, right? Like maybe one day modern science will be so great that you could just literally just like switch the eyes.
Yeah.
Switch them out.
Yeah. The other one I was going to talk about was the pistol shrimp. which is
Okay.
a shrimp that is essentially blind.
Hmm.
Very different from the mantis shrimp.
Wow. That's so you'd think that all shrimps would have similar types of adaptations, but
Yeah.
whoa.
I mean, there are so many different types of shrimps. I don't even know how many different types. As I was looking this up, I was like, holy crap, there's like a lot of different types of shrimp.
Yeah.
The pistol shrimp is named because it has a claw that's really like large. It's much larger than its other claw. And this very large claw it has like a little pocket. What the shrimp does is it pushes water into this little pocket in its claw, like so hard that the water shoots out and creates like this little bubble that then basically collapses in on itself very quickly and
Oh.
creates an extremely loud noise. It makes a sound louder than a gunshot. And
Whoa.
these pistol shrimp have been known to mess with underwater equipment because of how loud they are.
Oh.
And the little bubble that is made when they do this with this thing with their claw, it like shoots out and collapses in and creates like heat that's almost as hot as the surface of the sun.
What? Excuse me.
It basically shoots. It's basically a shrimp that can shoot little fire balls of air out of its claw.
Oh. Is that also mainly for hunting or defense or
Yeah, it's
combo?
I think it's for mainly for defense.
Okay.
Because typically these shrimp these shrimp are actually the reason I was looking at them was because they're typically known for having this very interesting symbiotic relationship with goby fish. It's actually really cute. Like this one would totally make a good children's story. Like,
We should do this one.
because the goby fish and the shrimp basically have this like very symbiotic relationship where the goby fish is basically like a seeing eye fish for the pistol shrimp. And because the pistol shrimp is blind, it basically spends most of its life just like digging its burrow. And so like digs its burrow at a very young age. And then it will make this like very small little opening right at the entrance that is just large enough for a goby fish tail. And goby fishes will go in, like they'll put their tail in this hole, and if the shrimp likes the goby fish, then they become friends and they spend their lives together.
Oh, that's
and
it.
and it's beneficial for the fish because the shrimp essentially like digs out its burrow, and then the fish can live in there and spawn in there. And
Okay.
and the shrimp also, like as it's digging up like the worms and stuff that the goby fish eats.
Mm.
So it's very beneficial for the fish. And then the shrimp, like there's videos of them online, and like the shrimp and the fish, they just like move around together, and
Oh.
the shrimp is pretty much always in contact with the fish and uses like its tail or something, or like its antenna to touch the fish's tail. And then the fish has like different patterns of flicking its tail to communicate with the shrimp what's going on around them.
That's the most adorable thing I've ever heard in my life.
It's so cute. It's so cute. And they basically just like are besties, and they like hang out together and live their whole lives just like
Oh,
hanging out, having this very adorable symbiotic relationship.
that's incredible. What happens if one of them passes before the other? Would they find a new one?
I
Or do they like
know.
pair for life?
That's a good question. I think they pretty much pair. I think they like bond, and that's their fish or their shrimp for life. Because I did read some studies that said that like sometimes there are shrimp and fish that they don't bond, like they don't find like a partner, and then and those ones don't live as long because they don't have like the protection, and they don't benefits of having the relationship. So
Yeah. Wow.
yeah.
That's
And
nutty.
the shrimp also benefits from the fish because it eats it eats the fish's excrement. It's
So,
probably not
perfect.
it's probably not the part that we'll include in the children's story about this, but
Yeah. Yeah,
um,
maybe not.
but it's but it makes it so it's like in the best interest of the shrimp to like dig its little burrow and like find food for the goby fish, so that the goby fish can eat and then the shrimp can eat.
Yeah, it's like the perfect pairing.
And that's so cute that they walk around like touching with their antenna like on the little tail, and the fish is like, oh, there's danger, we better go inside.
I know, come on, buddy.
And then they run into their burrow together. So cute.
That is so cute. I mean, it truly is like a human with a guide dog or something, where they're, they both benefit each other so well, and the human takes care of the dog helps guide the human, and that's amazing.
Yeah.
What I find so interesting about those two shrimps is, like, obviously they both have this incredible, powerful ability to either punch or shoot boiling water at things.
Yeah.
And so this very destructive, very pinpointed destructive thing that they can do, but one of them can see really well and one of them can't see very well. And it's interesting that they both evolved to have like a very intense either defense or hunting or whatever they use it for, but they did not evolve the same like type of ability to sense the world around them. And I guess the pistol shrimp's like, oh no, I need help. And whoop, there's the goby fish to help.
Yeah. It's very, I think it's really, it's really interesting that I wonder why, they didn't develop eyesight. I mean, I guess because they live in a burrow their whole life, and they, it's dark in there and they don't really need it unless they go out of their little burrow, which they do sometimes. And that's when the goby fish has to be like, okay, buddy, hold on to my tail.
Right. Wait for me.
Yeah.
That's amazing. I'm kind of shocked that there isn't a children's book already about. Maybe there is. Maybe we should look around.
Yeah. But and it was really interesting too that it sounds like from what I was reading that there are certain species of pistol shrimp like will only bond with certain species of goby fish. So like they're very like normal, common pairings that you'll see together because they just choose each other whatever reason. Like they have preferences on like what the other one looks like.
Yeah, that's incredible. Yeah, and I'm sure it has something to do with like, maybe they have slight differences in size or food preference or something, and that just like that pairing. And that's even more incredible that it happens across different types of goby fish and different types of pistol shrimp, that it's like that is a common thing that has evolved in this type of fish, not just one specific. Or is it all the same species? All the different, or there's actual different separate species?
I think there's I don't know. I'd have to look.
Okay. We'll have to do a follow-up episode. I feel like just
I know, because now you're asking me questions that I'm like, oh, I didn't look that up. Because I know that they're different colors, but I don't know if they're technically different species.
Yeah. Is it just like a variation, like a
like
breed? That's nuts. I love the pistol shrimp.
I love them. I think they're so cute. It's my favorite symbiotic relationship now.
Yeah. And I mean, there's a lot of good ones out there. I feel like that's one of my favorite things I think that's why I like wanted to study ecology in college, because like I think symbiotic relationships and like just like the ecology of that is just like one of the most beautiful, fascinating things of like different species in nature working perfectly together.
I know. It's like teamwork. Teamwork makes the dream work, you guys.
Yeah. And I guess, that I think our topics all relate with that too, where it's like ants are all about teamwork.
Yeah.
Pistol shrimp and goby fish, all about teamwork. We gotta work together. We have something to learn from the
mantis shrimp. The mantis shrimp just stays alone, but it's fine.
And punches things.
And punches stuff, but it's cool.
Sounds like a lot of people out there.
Yeah, that's
only
true.
Punching things.
Yeah.
Okay, cool. Anything else about either of the shrimps?
No, I think that's all I got.
Okay, awesome.
Yeah. Thanks for joining us today on Weird the Podcast.
You can contact us on Instagram at weird.podcast.
Subscribe to us on YouTube at Weird the Podcast.
Or shoot us an email at thepodcastweird@gmail.com.
Thanks, everyone. It's been weird.
So, I lost my train of thought. Let's see. So, are you ready?
No, I'm not ready. I'm not ready.
No, wait, I'm not ready.
I'm not ready.
Well, too bad. I know. I'm like breeding
Let's get some
mealworms
ant pets
in my room, and I have like
Yeah.
4 reptiles in there. And you know what I think it is? I think part of me is like, I don't know if my parents would want me to get. Am I allowed? Like, what? How many decades
I
have I
actually
been an
don't.
adult now?
Yeah.
Yay, this was a good episode. I really like these
Yeah.
topics. Maybe I'll cut out me struggling.